Close your eyes. You are floating somewhere above the Earth tonight, high enough that the planet has become a soft blue curve beneath you, low enough that you can still see the gold thread of a coastline, the quiet dark of an ocean at rest. There is no sound up here. There is only the slow turning of the world and the light of a few thousand stars scattered. Above you, like something spilled long ago and never swept away. Somewhere down there in a house with the lights off, someone is falling asleep exactly the way you are now. And somewhere out there, past the edge of what any telescope has ever touched, something else might be doing the very same thing. Tonight we are not going to chase the idea of aliens the way the movies do, with sirens and spotlights and streaks of green fire across the sky. We are going to do something quieter. We are going to follow the actual evidence, the real signals, the true and patient science that has, for decades now, been very softly suggesting that we are not as alone as we once believed. We are going to visit the oceans hidden under the ice of distant moons. We are going to drift past stars so faint and so red that they will still be burning long after our own sun has gone dark. We are going to sit with the strange, beautiful mathematics that scientists use to guess how many other worlds like ours might be turning somewhere in the dark right now. And by the end of this journey, you may find that the universe feels less empty than it did when you closed your eyes. Not more frightening, just less empty. Somewhere between here and the edge of everything we know, something extraordinary may be waiting. Let's go find out what it is. Let's begin, the way most good and quiet stories begin, with a single question, asked by a single man standing in a cafeteria a very long time ago. In the summer of 1950, the physicist Enrico Fermi was having lunch with a few colleagues at Los Alamos National Laboratory. They were talking, as physicists sometimes do, about flying saucers, which were very much in the news at the time. The conversation drifted, as good conversations do, into something larger. If the universe is so vast and so old and so full of stars, Fermi asked, then where is everybody? He did not mean it as a joke. He meant it as a real question, one built on real numbers, and it has echoed through science ever since under a name that now carries his own. The Fermi Paradox. It sounds at first like a puzzle designed to unsettle you, but sit with it for a moment slowly, the way you would sit with a stone you found on a beach, turning it over in your hand. Our galaxy alone contains somewhere between 100 billion and 400 billion stars. Try to hold that number for a second, and then let it go, because no mind is built to hold a number like that all at once. Instead, picture something smaller. Picture every grain of sand on a single beach at night, each one glowing faintly, each one a sun. Now picture that beach stretching for 100,000 light years, because that is roughly the width of the Milky Way, our home galaxy, the island of stars we live inside of. And our galaxy is only one of perhaps 2 trillion galaxies in the observable universe. 2 trillion beaches, each one scattered with its own 100 billion glowing grains of sand. Given all of that, given all that time and all that space, it would seem almost strange, almost mathematically uncomfortable, if Earth were the only place where something ever opened its eyes and wondered what it was looking at. And yet, as far as we can tell, so far, quietly, patiently, we have not heard a single voice call back. That silence is not evidence of absence. It may simply be evidence of distance and of time, and of how very young our own listening still is. We have only been capable of detecting radio signals from space for about a century. A century, against a cosmic history of nearly 14 billion years, is less than the space between one breath and the next. So let's slow down even further and look at how scientists actually try to answer Fermi's old question, not with guesses, but with careful, structured reasoning. In 1961, an astronomer named Frank Drake sat down at the National Radio Astronomy Observatory in Green Bank, West Virginia, and wrote out an equation on a chalkboard. It has come to be known as the Drake equation, and it is not really meant to give a single final number. It is meant to organize wonder, to break an impossible question into smaller, more human-sized pieces. The equation asks you to consider, one at a time, the rate at which stars are born in our galaxy, then the fraction of those stars that have planets, then the fraction of those planets that could actually support life, then the fraction of those where life does appear, then the fraction of those where life becomes intelligent, then the fraction of those civilizations that develop the technology to reach across space with a signal, And finally, the length of time such a civilization might exist and keep sending that signal out into the dark. Multiply all of those fractions together against the vast backdrop of the galaxy's star-forming history, and you arrive at an estimate for how many civilizations might be out there, right now, capable of being heard. Some of the numbers in that equation we now know with real confidence. Some of them we are only beginning to guess at, but the equation itself did something important. It turned an overwhelming question: are we alone, into a series of smaller, answerable ones, and slowly, patiently over the past 60 years, we have been answering them. Let's start with the part we now understand best, the planets themselves. For most of human history, we assumed other stars had planets simply because it seemed reasonable, but we had no proof. The first confirmed planet orbiting a sun-like star, a world called 51 Pegasi b, was not discovered until 1995. Think about that for a moment. For all of recorded history, for every philosopher and poet and priest who ever looked up and wondered about other worlds, there was no confirmed answer. And then only a few decades ago, the answer began quietly to arrive. Since 1995, we have confirmed the existence of more than 5,000 exoplanets, worlds orbiting other stars, and that number continues to grow every year. Much of that growth came from a single spacecraft launched by NASA in 2009 called the Kepler Space Telescope. Kepler did something almost meditative in its method. It stared without blinking at a single patch of sky containing more than 100,000 stars for years at a time. It was watching for the smallest possible dimming, a flicker so faint that it is like standing far away from a lighthouse and noticing when a moth drifts briefly in front of the beam. That flicker is the shadow of a planet passing in front of its star. Through that patient watching, Kepler taught us something extraordinary, something that quietly rewired how we think about our galaxy. Planets are not rare. They are the rule, not the exception. Current estimates suggest that our galaxy alone contains on the order of 100 billion planets, and that a meaningful fraction of them, perhaps hundreds of millions, sit within what astronomers gently call the habitable zone. The habitable zone is sometimes nicknamed the Goldilocks zone, and the name suits it well. It is the region around a star where the temperature is not too hot and not too cold, but just right for liquid water to exist on a planet's surface. Not too close to the star, where oceans would boil away into steam. Not too far, where they would freeze solid and still. Somewhere in that narrow, gentle band, a planet can hold water as a liquid, moving, shifting, catching the light of its sun. And wherever we find liquid water on Earth, however extreme the conditions, we find life clinging to it. We find it in boiling volcanic springs. We find it miles beneath Antarctic ice. We find it in the crushing dark of the deepest ocean trenches, where no sunlight has ever reached, and where organisms survive instead on the chemical energy rising from cracks in the sea floor. Life on Earth, it turns out, is far more stubborn and far more inventive than we ever gave it credit for. Which brings us to one of the most quietly astonishing shifts in the entire search for life beyond Earth. For a long time, the search focused almost entirely on planets like ours, warmed gently by a sun like ours. But in the last few decades, our attention has slowly turned toward moons. Cold, distant, icy moons, orbiting the giant planets of our own solar system. Let's travel there now, out past Mars, out past the asteroid belt, into the realm of Jupiter and Saturn. Jupiter has a moon called Europa, a little smaller than our own moon, wrapped entirely in a shell of ice. From a distance, Europa looks almost peaceful, its surface a pale, cracked canvas the color of old parchment, threaded with long, reddish lines that stretch for thousands of miles. But beneath that ice, something remarkable seems to be happening. Data gathered by NASA's Galileo spacecraft in the 1990s and refined by later observations strongly suggests that beneath Europa's icy crust lies a global ocean of liquid water. Not a puddle, not a lake, an ocean wrapping the entire moon, containing, by some estimates, more than twice the volume of water found in all of Earth's oceans combined. Kept liquid not by sunlight, which barely reaches that far, but by the immense gravitational pull of Jupiter itself, flexing and warming Europa's interior, the way you might warm your hands by rubbing them together again and again, for billions of years. Now travel a little further, out to Saturn, to a small bright moon called Enceladus. Enceladus is barely 300 miles across, small enough to fit within the length of a modest country. And yet in 2005, NASA's Cassini spacecraft discovered something that made scientists sit very still in their chairs. Plumes of water vapor and ice erupting from cracks near Enceladus's south pole, spraying out into space like a fountain, some of it falling back as fresh snow onto the moon's own surface, some of it escaping to form one of Saturn's faint outer rings. Cassini flew directly through those plumes, and what it found inside them included water and salts and organic molecules, the carbon-based building blocks associated with life. Later analysis even detected molecular hydrogen in the plume, a molecule that on Earth is produced by chemical reactions between hot rock and seawater, the exact kind of reaction that powers entire ecosystems around hydrothermal vents on our own ocean floor. In other words, a tiny, icy moon of Saturn appears to have a hidden ocean, warmed from within, chemically active, and venting its contents directly into space for our spacecraft to sample. We did not have to drill through miles of ice to look for life. The moon, in its own quiet way, was already showing us. Let that settle for a moment. Somewhere out past Saturn, in permanent starlit darkness, there may be an ocean, moving gently under a roof of ice, that has never once felt the warmth of direct sunlight, and yet may hold within it the same basic chemistry that gave rise to life here on Earth. We do not know, not yet, whether anything living moves through that ocean, but we know now that the ocean is there, and we know that oceans, wherever we find them, tend not to stay empty for long. Let's widen the view again and travel back out among the stars, because the search for life is not only happening in our own solar system. It is happening around other suns entirely, and here the story becomes even stranger and even more beautiful. In 2017, astronomers using the TRAPPIST telescope in Chile, and later confirmed with the Spitzer Space Telescope, announced the discovery of a small dim red star, only about 40 light-years away, called TRAPPIST-1. Around that single star, they found not one, not two, but 7 roughly Earth-sized planets, packed into an orbital system so compact that if you stood on the surface of one of them, the neighboring planets would appear larger in the sky than our own moon appears to us. 3 of those 7 worlds sit within the star's habitable zone. 3 chances around a single star, for liquid water, for the right temperature, for the quiet beginning of something. And TRAPPIST-1 is only one such system among what may be billions. Small, cool, red dwarf stars like it make up the vast majority of all stars in our galaxy, some 70 to 80% of them, and they burn so slowly, so patiently, that they are expected to shine for trillions of years, far outliving stars like our own sun. If life can take hold around stars like these, then the universe has an almost unimaginable amount of time left to work with. Now let's go further still, past 40 light-years, out to a planet called K2-18b, more than 120 light-years from where you are lying right now. In 2023, the James Webb Space Telescope, the most powerful eye humanity has ever built and pointed at the sky, turned its attention toward this distant world. K2-18b orbits within its star's habitable zone, and early observations suggested the presence of methane and carbon dioxide in its atmosphere, along with a possible, and still debated, hint of a molecule called dimethyl sulfide, a compound that here on Earth is produced almost exclusively by living organisms, particularly marine phytoplankton. Scientists have been careful, and rightly so, not to call this proof of life. The signal is faint, the distance is enormous, and confirming a biosignature, a chemical fingerprint that could only be explained by biology, is one of the most difficult things astronomy has ever attempted. But the fact that we can even ask the question, the fact that we can point a telescope at a point of light more than 100 light-years away and begin to analyze the chemistry of its atmosphere, would have seemed like something closer to magic to any scientist working even 30 years ago. We are right now, in your lifetime, in the earliest days of actually being able to check. Let's slow down here because this is worth sitting with. For nearly all of human history, the question of life beyond Earth belonged entirely to philosophy and to imagination and to myth. The ancient Greek philosopher Epicurus wrote more than 2,000 years ago that there must be infinite worlds, some like ours and some unlike ours, scattered through infinite space. He had no telescope. He had no evidence. He had only reason and the quiet confidence that the universe was too large to waste on a single story. Now, slowly, gently, across the careful work of thousands of scientists and centuries of patient observation, that old philosophical guess is finally beginning to meet its evidence. We are the first generation in the history of our species that can actually look, and what we are finding again and again in ice-covered moons, in the atmospheres of distant worlds, in the sheer staggering abundance of planets scattered across the galaxy, is that the raw ingredients for life are not rare at all. Water is common. Carbon is common. The building blocks of amino acids have even been found drifting inside interstellar clouds. And embedded in meteorites that have fallen to Earth, chemistry already halfway toward biology, formed in the cold dark of space long before any planet existed to receive it. The universe, it turns out, seems to want to make the ingredients for life. What remains far less certain is how often those ingredients actually assemble into something that lives and breathes or grows or dreams. Let's return gently to Fermi's old question, because we are finally ready to look at it with new eyes. Where is everybody? One answer, offered by scientists over the decades, is simply this: we may be looking too early. The universe is enormous not only in space, but in time and civilizations, if they exist, elsewhere, may rise and fall like brief candle flames scattered unevenly across an almost endless night. Our own civilization has only been capable of sending a detectable signal into space for about 100 years, a blink, a single held breath, against the nearly 14 billion-year history of the universe. If another civilization, somewhere among those 100 billion stars, existed for 100,000 years and then quietly ended, and did so 500 million years before we developed radio telescopes of our own, we would never have heard them. Their light would have already passed. Their silence would look to us exactly the same as if they had never existed at all. This is sometimes called the temporal argument, and it carries a certain aching, tender sadness to it. The idea that the universe might be full of stories we simply arrived too late or too early to hear. But it also carries something like hope, because it means that silence is not proof of emptiness. It only means that the timing so far has not lined up. And so quietly, patiently, we keep listening. In 1974, scientists at the Arecibo Observatory in Puerto Rico sent a radio message outward, aimed at a cluster of stars called M13, 25,000 light-years away. The message contained simple pictures, encoded in binary, describing our numbers, our DNA, our solar system, and a small figure representing a human being. It will not arrive for another 25,000 years. If anyone answers, that answer will not arrive back on Earth for another 25,000 years after that. Whoever sent that message knew, with absolute certainty, that they would never hear a reply in their own lifetime. They sent it anyway. There is something achingly human in that gesture, a message in a bottle thrown not into an ocean, but into the dark between stars, carried by nothing but light and patience. In 1977, NASA launched 2 spacecraft, Voyager 1 and Voyager 2, each carrying a golden record, an actual physical disk containing greetings in 55 human languages, the sounds of wind and thunder and whale song, and 90 minutes of music from cultures all across the Earth. Both spacecraft have now left the solar system entirely and are drifting through interstellar space, carrying that golden record outward at more than 30,000 miles an hour. They will likely still be drifting, silent and golden, long after the sun itself has swollen and faded, long after the Earth itself is gone. We built something to outlive us and sent it into the dark simply on the chance that someone someday might find it and wonder about the small blue world that made it. That is not science fiction. That is a real object, moving through real space, right now, tonight, while you lie here listening. Let's slow the pace even further now, because we are drifting into the deeper, quieter part of this journey. The organizations searching for extraterrestrial intelligence today, groups like the SETI Institute, Use radio telescopes to scan the sky for any signal that could not be explained by natural processes, a signal too narrow, too structured, too deliberately patterned to be a pulsar or a star or background noise. In more than 60 years of listening, we have found a handful of strange, unexplained blips. The most famous is called the WOW signal, detected in 1977 by a radio telescope in Ohio, a burst of radio energy 30 times stronger than the background noise of the sky, lasting 72 seconds and never repeating again, despite decades of searching the same patch of sky afterward. We still do not know what caused it. It may have been a natural phenomenon we do not yet understand. It may have been noise or reflection, or something entirely mundane. Or it may have been something else. A single word from a very long sentence we were not yet listening closely enough to hear in full. We may never know. And there is a strange, unexpected peace in that uncertainty, if you allow yourself to feel it. Because the not knowing means the story is not finished. It means the universe still has room in it for wonder, for open questions, for things that have not yet been explained away. Let's drift outward once more, past the radio telescopes, past the golden record, past the ice moons and the red dwarf stars, and consider for a moment the strangest possibility of all. What if the reason we have not found other civilizations is not because they are rare, but because intelligence itself, of the kind that builds radios and telescopes and golden records, is only one small chapter in the story of life? On Earth, life itself appeared astonishingly early, within perhaps a few 100 million years of the planet cooling enough to hold liquid water. Simple single-celled life seems to be almost eager to begin, wherever conditions allow it. But complex life, life with organs and nervous systems, and eventually the kind of mind capable of asking where is everybody, took more than 3 billion additional years to arrive. For most of Earth's history, if an alien astronomer had studied our planet from afar, they would have found only oceans of microbes, patient, ancient, and utterly silent to any radio telescope. If life elsewhere follows a similar rhythm, then the universe may be quietly, invisibly full of life, oceans of it, microbial and ancient and utterly silent, simply because so few worlds have had the time or the luck to cross the enormous distance between simple life and a mind that looks up and wonders. That is not emptiness, that is patience on a scale almost too large for a human mind to comfortably hold. And if that is true, then it means we are, in some very real sense, part of something extraordinarily rare and new in cosmic history. Not because we are alone, but because we may be among the first sparks of complexity to look outward and ask the question at all. Let's come back now, slowly, gently, the way a boat drifts back toward a familiar shore. Think again of yourself, floating above the Earth at the very beginning of this journey. The blue curve of the planet beneath you, the quiet dark scattered with a few thousand stars. Only a few thousand, out of the 100 billion in this galaxy alone, out of the 2 trillion galaxies beyond it. Somewhere among all those unseen stars, there may be an ocean moon we have not yet visited. There may be a red dwarf star with 3 green worlds circling it in patient orbit. There may be a planet where, right now, in some form we cannot yet imagine, something is lying still in darkness, listening to its own version of the wind, wondering, in whatever way it wonders, whether it is alone. We do not know its name. We may never know its name. That life in some form somewhere may be closer than we have ever imagined, not descending from the sky in ships, not hiding in shadows at the edge of a photograph, but floating, right now, in a dark ocean under ice, or drifting as a single strand of ancient microbial patience beneath the clouds of a world we have only barely begun to see. You do not need to solve this tonight. No one has solved it yet. Not even the scientists who have given their entire lives to the question. You only need to rest inside the wonder of it, the way you might rest inside a warm and enormous room, too large to see the edges of, but somehow still entirely safe. The stars above you have been burning for longer than you can imagine, and most of them will keep burning long after you have drifted off completely. Somewhere among them, quietly, patiently, the universe is still deciding how many stories it wants to tell. And for tonight, you do not have to wait for the answer. You only have to close your eyes and let the question carry you gently outward past the moons, past the red stars, past the golden record still drifting in the dark, out toward sleep, out toward the soft and endless quiet where all of this began. Rest now. The universe will still be here when you wake. And so, perhaps, will someone else.